We have here English to mathematics. I'll give you a sentence, more English than maths, and you have to change it to a correct maths sentence. Add a bracket to another bracket. Can you feel it? That you start off with the bracket at the back, and then you add the one in front. Like this. You get rid of the brackets, you add all those that are the same type, same sort, and you get to your answer. So to add two brackets to each other, you can start off with a plus in between, but rather start off with a one at the back, because if you read that, you should actually know that the last one I have firstly, and then I've got to add the first one to it. 4.2 now. Subtract a bracket from another bracket. Subtract. Read it carefully. You have to subtract something from the end one, and the end one is what you've got to start with. So subtract this from that. I can put it in another way to say take the last one and then minus the first one, as I've done there. Subtract something from something else. The one that is secondly given, you've got to actually put that first. Subtract this one's got to go last, and that one is going to get first. And now get rid of the brackets. Remember to multiply that minus with each one inside, and the plus one in front of that, and then add those that are the same. There's another example here. Subtract minus x minus 2 from 3x minus 7 from that one. So start off with the back one, start off with the 3x minus 7, and then subtract all those negative numbers. Put it in brackets. Of course you have to put it in brackets so that you can multiply the minus with a minus to get to that plus. If you don't put it in brackets, there will be sign errors when you calculate these last two steps. So subtraction, very carefully, it have to be in the right order. The one that you subtract at the end, and the one where from you subtract in front. 4.3 now. Subtract minus 4x from that one. They're the one that you have to subtract it from. You have to write that one first, and then the negative sign, and then your negative minus 4x. So we have two minus signs there. When you multiply that with a distributive law, or if you get rid of the brackets, then that'll become a plus, and in front of this bracket is a plus 1, so the signs does not change, it stays exactly the same, and you have the 5x and the 4x to get to 9x, and there's the 5 at the end then. 4.4 is the same. Just see the order that I've written this English to maths. A bracket, add a bracket and another bracket. Doesn't matter when you add the adding sign, or to add doesn't really matter, because you can swap it around. That will not matter. So you could have written the last one first and that one there. You should get the same answer. It's that minus, the subtraction, that you have got to be very careful with. So just put a plus sign in between these two brackets, get rid of the brackets, and add those that are of the same kind. 4.3 and 4.4. 4.5 and 4.6. 4.5 is no x here, it's only minus 19 that you have to subtract from minus 38. Now, which one first? The number or the value after the word from. Now, from something means that minus 38 has got to go first. Minus 38 minus 19. That's what is asked here. Subtract the minus 19, so the minus 19 in the second place, from that one. Now the one that you've got to subtract it from is the one that you have to write first. Minus 38 minus minus gives you that plus, and at the end you end up with minus 19. Don't use your calculator, because I really don't know how you're going to punch that in so that you can get to minus 19. If you punch it in the wrong way, then of course you will not get the right answer. You will get plus 19, and plus 19 is not the correct one. It should be minus 38 minus 19. For 6, the same. Now look here, I've not given you all the brackets. You have to put in the brackets yourself. Subtract 14 from. Now if you just read till you get the word subtract. Now if you have subtract, you actually write down 2 sets of brackets with a minus sign in between with nothing in it. Start off with that. Now read further. Subtract 14. So the 14's got to go in the second sets of brackets. From what number should you subtract? So in the first bracket then, the sum of minus 18 and 26. So minus 18 plus 26 is the sum of those. So start off with the 2 sets of brackets, that one and that one with a minus sign in between, and then you read it again to see which is which and what number should go into which brackets then. Minus 6, the answer. 4.7, subtract something from the sum of those two. Sum is to add. To add minus 9x and 30x. So add that from that. So put that in the first bracket and subtract. That's that minus, and the minus 25x, it's what you've got to subtract it from. So if you have the brackets, it's easy. Get rid of your brackets with a distributive law. Multiply that minus with that minus to get to that plus 25x. The first answer is 11x, and together that'll give you 36x. 4.8, a little more difficult, yeah? 3 stars. Divide the bracket by 2. And multiply the answer by that bracket. So first get your division right there in the first bracket, divide that, and then multiply. There's a multiple sign there. Now in the first case we have to divide each one of those on top with the 2 underneath them. Write it like that so that you can cancel out and get to the 6x plus 3. That's the answer of those 2 terms there. So 12 divided by 2 is 6, and there's a x on top, so 6x plus, and 6 divided by 2 will give you 3. Now we have a bracket that we have to multiply with the other bracket. Now I do like the one term in front. You can swap that around. The commutative law will allow you to do that. So put the minus 3x in front, and now you multiply each one with each one. Minus 3x times 6x, first the signs, that will give you that minus. 3 times 6 is 18, and x times x is x squared. Now the minus 6x with a 3 will give you minus 9x. Just have a good look at the whole question. We have the distributive law for division in here and the distributive law for multiplication in the same question. 4.9, how much is 10x less than minus 20x? So 10x must be less, so first write the minus 20x and then you subtract the first one. How much is that less? So we anticipate that that one is the smaller one and that one is the larger one. Don't look at that minus sign because the x can be a negative as well. So this one is the less one and that one is the bigger one. Subtract them from each other and get minus 30x for your answer. For 10, subtract the difference from that and that if you add them from that one. So the from, that last bracket, then write that down first and then you subtract because that's a minus, and then the difference between those two in the bracket with a minus sign in between them. I think this is rather difficult, and to write it in the correct order because there's a lot of minus signs and negative numbers, please be careful. If you have that, of course, you can just get rid of the brackets, distributive law, multiply with the 1 in front and that minus with each one of them. Don't forget the minus and the minus together is a plus, and then all those that are the same. You will get 5x plus 9y when you add all the x's and all the y's. For 11, watch out. We have to subtract the following. Now the black ones is given, and to subtract it I've written the red brackets and put a minus sign in front of them. Now before I do this question, it could have been like written like this, and you can actually change it to make it look like this. I have the top one with the 4 terms in it, and I have to subtract the minus and then all this with the plus and minus signs. Be very careful if you write it down. If you have the two brackets not on top of each other but next to each other, it is more like the ones we've done at this stage. Now the reason why I do this is to actually show you that if you can put these underneath each other, I think it would be much easier to get the answer. But if this is more practical for you, write it next to each other. Get rid of the brackets, please. Minus times minus is a plus. That minus with each one of those, you've got to change the signs there, and then see that you get all those that are the same sort, get them together. There's a 2x cube and the 6. That'll give you that 8. For the squares, there's minus 4 and there's minus 5. That'll give you minus 9, and so on and so on. So this is the same answer as that I have there in red. How do I do it when it's underneath each other? Well, of course, you've got to change the sign. That minus times that minus, it's also multiplication there, is a plus. And then if you've got this the different kinds or types on top of each other, then it's easy because there's 6 of them and then plus 2 of them, and you will also get that 8x cube, the same as I've done here. The squares are under each other, but we have to subtract. There's another minus sign there. Minus that plus will give you minus 5x squared together with a minus 4x squared will give you minus 9x squared there. That minus sign multiplied with that one will give you the plus 2x, and plus 2x and 15x together is this 17x. Minus times that minus is plus 7 minus 3 is plus 4. So all I've done here, I've written it in such a way that those that are the same kind are underneath each other. If you don't like that, write it like this, next to each other, so that it can be of the same that we've done till this, and get the same and the correct answer, please. For 12, you have to add those underneath each other. Look at the black ones first. All the same kinds are underneath each other. There's those with no x. There's the x to the power of 1, and there's the squares underneath, and there's a cube underneath. We have to add it, so there's another plus coming between them. Now if you have a plus in front, the signs does not change, and of course there's a plus 1, so the numbers will not even change, so it stays the same. So just add them. 6x to the third minus 2x to the third will give you that 4. There we have minus 4, and when we add the 5 we will get 1x squared. 15 minus 2 of the same will give you that 13, and now minus 3 minus another 7, because sign doesn't change. It's a minus 7 and a minus 3, and that'll give you that minus 10. For 13 is to subtract. I've given you the black numbers. To subtract, you have to put in another minus sign there, as I've done that minus red one there. So all the signs of the bottom ones will change if I multiply it with that minus. The numbers will not change because there's only minus 1 there. So let's start from the beginning. Minus 1 times minus 2x cubed will be plus 2x cubed with that other one there. That'll give you that 3. The minus with that plus is a minus 5x squared minus another one is minus 6 of them. That minus times that minus will give you that plus 2x plus another x, 3x plus 3x. The minus times that minus is plus 7 then, and minus 3 is plus 4 for the answer. For 14 now, if you look at your study guide and there's 414 there, you will see that there are no zeros in those places. Now you can leave it out, it is exactly the same, but just to explain this I've written down the 0 and try to explain it here. That's a placeholder. You put all the similar terms underneath each other. There's a 6 of them and a 2 underneath, and all those are x squares. Those have the x's, and there's your constant at the back. Now we have to subtract it, so the signs are going to change. Take that minus, multiply it with the first one, get minus 2x cubed, and add it to the 6 of those on top. 4x to the power of 3. If you take that as a 0 and you subtract minus 4, then you'll end up with minus 4x squared. If you don't have the 0x squared there, of course you should have written it there, but the minus times that one will be minus 4x squared, and then when you add nothing to it, you also get that minus 4x squared. All the way down to that 0 now, minus 3 minus 0. So it's only going to be minus 3 left. So that zeros that I've written there is not necessary. You can leave it out, but you have to, when you do the question, see it as a 0. It's only to explain it that I've written it down here. I've done the same here with 415. There is no x cubes in the above one, so just write 0 there as a placeholder, and then you can subtract. So please remove all those minus signs there and there and make them a plus, but in your head, not on the paper. We've got to see that the minus was given, so don't actually scratch it out and put a plus in its place. In your head, minus times that minus is a plus, and a plus 2 plus a minus 4 is minus 2. Do it so that it looks the same as this one when you finish. Don't actually change that signs in real life. In your head, yes, you change it because there's a minus in front. Let's start from the beginning now. Minus times that plus 12x cubed will give you the minus 12 together with the 0 is still minus 12x cubed. That minus changes that one to a plus. Plus 2x squared minus 4x squared is minus 2x squared. Minus times that minus is a plus. Plus 2x minus 15 is minus 13x. That minus times that minus is plus 6. Plus 6 minus 13 is minus 7. For point 1, you have to change the letters with numeric values. Substitution. 2x plus 1 if x is 4. I know it sounds quite easy. The one thing that I want to actually try and teach you in the beginning here is when you substitute, when you change the letter with another value, please put your brackets in. Now this one is easy because it's plus 4, but say for instance that was minus 4. then you are going to make some sign errors if you don't put that in a bracket. So write down your question so that you can see what you changed. So the 2x plus 1, if x is 4, equals 2 times the x, and in x's place you put down the 4, and then you simplify it to your answer. 5.2, we have 3x squared minus 2x, and the x becomes minus 1. So put that, both those x in brackets, and inside the bracket a minus 1, and then you simplify. Remember, minus 1 squared is plus 1, minus 1 times minus 1 will be plus 1, multiplied with that 3, get rid of the brackets of course, 3 times 1 is 3, and there you have minus 2 and minus 1, minus times minus is plus, so plus 2 plus 3 is that 5 there. At 5.3, I have x's and y's, and I've given you values for the x and for the y. So you have to substitute each variable with the value by putting them in brackets. There's the x in bracket with a 2, the y in a bracket with that 3, then you have that minus, only the x in a bracket, substituting the 2 there, and then the 3 at the back, minus 3. And when you've substituted every variable with the 2 values, there are x's and y's here, you have to simplify it, get rid of all the brackets, and get to your 7. 2 times 2 is 4, 4 times 3 is 12. There's minus 2, and there's a minus 3. Altogether gives you that 7. 5.4 now, x cubed minus y cubed. Now that's not too bad. What is bad is that minus 3 there, the substitution of minus 3. If you don't put that x and of course the y in a bracket so that you can substitute the minus 3, I am very much sure that you will make a sign error. So put it in a bracket. The y as well, the y has got to be substituted by minus 3. So if you can just get that step there, then of course it is simplification further on. 2 to the power of 3 gives you 8, minus 3 to the power of 3, minus 3 times minus 3 times minus 3 is minus 27, and there's another minus sign, so at the end you have plus 27. 35, the answer. This one we have x to the power of 10 minus x to the power of 11, and the x is going to be minus 1. So substitute the x, not the 10. The substitute with the minus 1, and that x also with minus 1. Now I have here an exponential exponent of 10, and then that one is 11. So that one is an even number. So minus 1 times minus 1 times minus 1 10 times, that will give us an even number of minus 1s multiplied with each other. So each 2 of the minus 1s will give you a plus. So if whether that is 10 or 20 or whatever, it is even. So 2 of those will give you a plus 1. So if it's an even number on top of the minus 1, the power of 10, so your answer is plus 1 there. But the next one is 11, and that's an uneven exponent, so minus 1 to the power of 11 will give you minus 1, an uneven number there. But there's another minus as well, so we will get that plus to get to the answer of 2. If you can get this one correct, that's rather clever. Be careful here, because I've given you round brackets. You've got to substitute, and you've got to put that into brackets. So take another set of brackets. It's easier to put the block ones at the end and substitute the x with a minus 13 inside its own bracket, and the y with that 7. Get rid of that round brackets then. So inside the block brackets, we've got to get that answer. Minus 13 plus 7 is minus 6, and then of course you have to square that to get to 36. 4.7, have a look at the answer. Did you see that I've substituted the x with a 3 inside a bracket? That x is also substituted with a 3 inside a bracket, and the y value is 4, so I have two brackets there next to each other. I have two brackets there because that's what the square means. So 3 times 3 is that 9, and 2 times 9 is the 18. We have there 3 times 4, 12, and we've got to multiply it with a minus 1 in front. 18 minus 12 then, and your answer is 6. Another way of asking you to substitute is to give you the functional notation. Now, it's like that, f with a bracket of x. Now, the name of this expression will be f. It can also be a g or a h or whatever. The name is an f. So in the f expression, you've got to change the x with whatever they ask. So just look at this example first. If fx is x squared plus 4x plus 3, the name of that three terms, we call that an f. The variable is x. Now we want you to calculate f of 2. Now f of 2, if you write the f of 2 underneath the f of x, then we have the f's that are the same and the x becomes a 2. So it's another way to tell you to substitute each and every x in a bracket with the number 2. And then simplify, of course. So this is the functional notation. We are going to use this much more than the other one when we do graphs, so it's very important that you know this notation. I give you an expression, the name of it is f, and I do ask you to get f of 2. It means the x must be changed to 2. Let's do 5.8 in this example as well. If x is x plus 3, determine f of 2. Write it underneath each other so that you can see the x becomes a 2. Make that x and 2, and your answer will then be 5. The answer is then f of 2. The function when x is 2 is a 5. And then you actually simplify till you get a nice answer. 5.9, the function notation. That's a function 3x minus 12. You will in due time learn that that is a graph, a linear graph, and if you actually substitute the x with a 2, you will get the y answer, but that will not matter at this stage. This is a functional notation. The function's name is f. It can be a g and a h, anything, but the variable that you have to substitute or change is an x. So f2 means the x becomes a 2. Make that x and 2 in a bracket, please. Multiply to get to 6, and 6 minus 12 is minus 6. 5.10, exactly the same. The name of that function is f. The variable is x. And do you see there's only one? We can only put this in a way that you can only substitute one, the x, for instance. Not if there's a y and a z in that expression, you can only substitute one of those variables. So f2, the x must be 2. In a bracket, please. 2 squared will give you the 4. 6 times 4 is 24. And if you subtract 3, then you'll get that 21. 5.11, we have a functional notation, but in your expression there's an x and a y, but it is given that the name is f and the variable is x. So if I ask you to get f2, then you have to change the x with a 2. So f2 then is 2 times 2, but the y, we don't have something to substitute the y with, so leave the y in your answer. Little more difficult is this one. We need to get f1, but fx is given. So the x has got to be substituted with the 1, the y's must be left alone. So 1y there and a minus 3y there gives you minus 2y in your answer. 513, I can do this one as well. For some reason, pupils get this, find this a little difficult. F of 0. So that's an x there that you have to substitute with a 0. So in a bracket, please. Leave that minus outside, leave the 2 outside, and the x becomes a 0. So here we have 0 times 0 with a minus sign in front, that's 0 again. That one, if the x becomes a 0, it's also a 0, and you have the minus 2 left at the back to be your answer at the end. 514, fx is given. Functional notation, the name of those two terms are f and fx. The x is the variable that we want you to change to make the x a 1. f1's asked, so every x, there's only one here, change that to an 1, put that in a bracket please, so that you can actually get used to putting it in brackets. If it's negative numbers, of course, that's more important, but try and learn that so that you can always put those letters that you change in brackets. So 12 minus 8, the 4 then for our answer. We have here the minus 1, and I can assure you if you do not put those minus 1s in brackets, you will not get the right answer. You will make sign errors there. So the x, change the x to a minus 1 in that expression. So the x minus 1, that x is also minus 1. If you changed or substituted each x with a minus 1, then you have to calculate that. First, get rid of all the brackets. Minus 1 times minus 1 times minus 1, 3 times, not times 3. Minus 1, 3 times with each other is minus 1 then, the sign as well. That'll give you that minus 2. There you have the minus 4 if you multiply the plus with a minus, and a minus 8 at the back. Altogether, minus 14 then. 516, it gets a little tricky. Not the expression, that's easy. If x is x plus 12, that's an easy one. But look what is asked. f3 plus f minus 1. It's a double question. So first get the f3. Now I've colored it in with yellow there, f3. You can work out what is f3 as you've done with all the previous ones. Get f3's answer, that's 15. Then get f minus 1's answer, that is 11. And then you have to add those. But our mathematicians, we don't want them to be separated. Do it all together. So f3 plus f minus 1. When it's f3, go to your expression and substitute the x with a 3. There you are. 3 plus 12 will give you that 15, the yellow ones. And then add to it f of minus 1. So the x must be minus 1 in a bracket, please, because that could be a rather difficult one. This is easy now. It can be more difficult. So minus 1 plus 12 in the same way as you've learned in the previous ones. Get to that 11, and then you add the yellow and the blue ones to get to 26. So this is a combination of the functional notation, f3 plus f minus 1. f17 now, fx equals 2x. Determine. Now, what is that? That is 5 times the f of 2. Just look at that one and try to understand. If I asked you in all the previous ones, what was f2 or f3 or or F1 or F0, doesn't matter. How does your answer look? Your answer is a numerical value. So if I ask you 5 times F2, then it's exactly the same as to ask you 5 times the value of F2. Now F2 means you've got to go to the F expression and make the variable 2. So there's Fx. So the x becomes a 2. 2 times 2 will be 4. So that question there becomes 5 times the answer of that. The answer of that is 4, so that your total answer will be then 20. 5 times f of 2. Now this kind of questions we could not have asked you by only asking to substitute. 5 times the f of 2. And of course I can make it more difficult, and I can say right there and add 3 times f of 3 and divide both of them with something else. You can make a whole new question there with combinations of plus or adding, subtracting, multiplying. This is a multiplying one, and of course the divisions. It can all become a new kind of question. 5 times f of 2. Get f of 2 and multiply it with 5. A 4-star question. F times the f of 3. F times the f of 3. Now the f of 3, start inside. The f of 3 is going to be that part tilde there. Let me just color it yellow for you. There you are. If you can get the answer of f of 3, the middle f of 3. Now what is f3 is going to be? f3 is when you go to the expression and change every x with a 3. So 3 plus 1 then will give you that 4. So fx is x plus 1. So f3 will be 3 plus 1. 3 plus 1 there is the same as f of 4. So the one given on top is exactly the same as the one there, f of 4. And now you've got to go back to your f expression and substitute the x with that 4. This is a double one to be substituted. First a 3 in it, and then a 4 in the same one, and your total answer will be then the 5. One of the advantages of this functional notation is that we needn't substitute with a only with a number, but also with another expression. So fx, and we want fx minus 1. So if you do exactly what I've taught you till now, the x becomes an x minus 1. So go to your expression, put a bracket round. I hope that you've learned to put the brackets there, otherwise you won't be able to do this question. Put that x in a bracket and substitute the x with a x minus 1. Just have a close look at that one. There's the 2, and now the x in a bracket becomes x minus 1, close your bracket, and then the plus 1 at the back. Now there's the distributive law, multiply in and add those 2 at the back. 2x minus 1 is then the answer of the f of x minus 1. So now we can actually change each letter with a combination of letters as well. We don't need only a 2 or a 3 or whatever there. We can substitute a letter or a variable with another expression like I've done in 519.
With question 6 you have mixed questions. There is no video. Please do the questions and bring it to your tutor for marking.
Exercise 7, linear equations. Now an equation is two expressions with a equal sign in between. You have then the equal sign, linear. So linear means the power of x should be 1 and not a 2 or anything else. If it's a 2, then it's quadratic. So we stick to the linear ones in this exercise. Linear, x to the power of 1 then. Equations, the equal sign. Now if you have an equal sign in the first step, then it's very, very important that all your equal signs will be underneath each other. And in front of the second step, in front, you don't put an equal sign, you put a therefore sign, that 3 dots like that. And of course that means from the previous, that's the 3 dots, therefore. Now an equation, equal sign, means that the one side is the same as the other. Now we can change that equation, but if you change one of the sides, you've got to change the other one as well. Otherwise they don't equal, they don't balance, as we've done with that the other ones. It's not the same then. So let's start off with the linear equation. It starts off very easily, and just remember the first ones. The question is to solve your x, solve the x. I can also ask the same question by just putting the words determine the value of x, get the value of x. Solving an equation means determine the values of the variables of which the equation is true. Get all the answers of x so that that equation is true. But there's another one as well, and this is the third dot here. If we have, say, a few different letters, different variables in the same equation, then it's common knowledge to say or to write down, make x the subject, and that means get x on its own. And all the other, the numerical values, all the other letters, all the other variables, all of them will be on your right-hand side, and then the x on your left-hand side. The x will be on its own. If you look at the first 4 questions here in exercise 7, for 1 to 7.4, we have exactly the same values, but a different question. X plus 3, and then the x minus 3, and then 3x, or x times 3, and then x divided by 3. So I have all 4 of the calculations with the x. Now your method is the following. You've got to get rid of all the other numbers that are together with the variable on the same side. There's a plus 3, so get rid of the 3. There you have to get rid of the minus 3. There you've got to get rid of the 3 times, the multiplied by 3, and there the division of the 3. So get it on its own so that you can get your x on its own. Now the way to do that is the following, and I want to show you in this demonstration, because if you look at the answer, then I've already done this. Say for instance that one, x plus 3 is 15. Now don't speculate, don't think, just write your x. And if you've done that, then you look at what you've done. There was an x plus 3, now there's only an x, so the plus 3 is gone. Now ask yourself, how did you get rid of that plus 3? And of course, if you do it on the one side of the equal sign, you've got to do it on the other side as well. So to get from x plus 3 to that x, you have to subtract 3 from the 15, so that answer then there will be 12. Take the next one. X minus 3 is 15. We've got to get rid of the minus 3. Now get rid of it. Just write down the x. And now you discuss it and you think about it. How did I get rid of minus 3? Now to get rid of minus 3, you've got to do the opposite of it. Minus 3 plus 3 will be 0. So on that side, for the x minus 3, to get to the x, you added 3. So if you add 3 on the one side, you have to add 3 on the other side as well. So that answer next to the equal sign will be 18 then. In this case, 3x, leave the 3, just write down an x. Now ask yourself, what did you do to get rid of the 3? Now 3 times x, to be 1x, you had to divide by 3. And if you divide by 3 on the one side, then divide by 3 on the other side. So x will be 5 then. This one, the last one, if you divide it by 3, a third of x. Now leave out the third, just write down the x and ask yourself, now what did I do to get from 1/3 x to 1x? Now that is 3 times more. So if you've done times 3 there, then do it on the other side as well. The answer will then be 45. This one is number 4. I've given you the answer there, and I've shown you what you've done. Do not show how you multiply. The reason, therefore, is if you do it correct, then of course it's correct. But if you only multiply on the one side and not on the other side, then of course I have to subtract 2 marks for you, because that is not actually a simple error, it's a major error then. So in this case, there's not many of these places, but in this case, do not write everything. Write the answer there, and then the answer at the other side, and then it's more easy to get that correct. This is the first 4 of exercise 7. 7.5. Minus x over 2 equals 6. You have to solve x, or get the x on its own, or make x the subject of that equation. So you have got to get rid, in this case, of the minus in front and the 2 underneath. So the first one's first. The one that is the furthest away from that x, that's the 2. Get rid of it firstly. So to get rid of dividing by 2, you multiply with 2 there and multiply on that side. Now that step, if you have it correct and you multiply each side, then of course that is correct. If you cannot do that, and if you only multiply the one side with a 2, then you made a terrible error, and I have to subtract 2 marks for that. So rather leave that step out. Multiply by 2 there to get to minus x, multiply the 6 with 2, get to 12, divide by minus 1 each side, and you'll get the answer a little easier. 7.6. I want to know the value of x. So x is the unknown. X is the unknown one. What is x? Solve x. Get x on the one side. Make x the subject of this equation. All the equal signs are underneath. There's the therefore, the 3 dots in front, no equal sign in front. Now there's a minus 3 and a 4. Firstly the 4, that's the furthest away from the x, so multiply with 4 on each side. Multiply that one with 4, you get the minus 3x, and multiply that one to get to the 24. Then to get rid of the minus 3, you divide by minus 3 on each side, and x will be minus 8. Write your answers so that you don't make that error of just multiplying or dividing on one side. What I teach my pupils in the classroom is the following. If you want to get rid of that divided by 4, well, get rid of it. Don't write it. Just write minus 3x. If you've written minus 3x, then ask yourself, what have I done to get that one to this one? And the dividing by 4 is gone now, so multiply by 4. That's what's happened there. Then do the same on the other side. Now again, minus 3x. Get rid of the minus 3, just write down x. And then you ask yourself, what have I done to get rid of the minus 3 to be plus 1 there? And it's dividing by minus 3 to get to plus 1. So divide the other side also by minus 3. 7.7. There's the x. There's the x that you have to solve, or to get the value of it, so that that whole equation, that's an equal sign, that's an equation. Look at all the equal signs underneath each other. It should be like that, because you write the equal sign first. If you have that one, then first write the equal sign so that it can be underneath, and then you write down what's left on your left hand side and the right hand side as well. So there if you want to solve x, you've got to simplify first, and that's why I've used the distributive law to get rid of the brackets. So 2x plus 8 plus 1. Now the one side and the other side, make both of them as small as possible. Simplify both of them. So just add the 8 and the 1 to get to the 9. And now you have a simple left-hand side, a simple right-hand side. To get rid of the 9 and the 2, to get that x on its own, start your solving process now. The one that is the furthest away, that's a 9, get rid of him. So don't write it, 2x on its own. How did I get rid of the plus 9? I subtracted 9 to get to that 2x, to make that left-hand side this left-hand side. Subtracted 9 there, and you do the same then on the other side. Now, I don't want that 2 in front, so write it without the 2, and ask yourself, what have you done? To get rid of that 2, I divide it by 2. So that one divided by 2 will give you this, and that one divided by 2 will give you the 1 there. So first, simplify both ends of the equal sign, and then start your solving process. 7.8. This is a simple question, but a very difficult one to explain. I want x on its own. Now, if you look at that equation, you have an x on the one side and the x on the other side. You cannot actually take one of them and give an answer with the x on the other side. That will not be correct. You've got to get all those x's together first, and then you start solving it. So, as we've seen in 7.7, you have to simplify first. Now, if you have simplified, if there's any brackets, just get rid of it. If there's something on each side that can be added or subtracted or whatever, do that to simplify. But then, if it's already simplified, that left-hand side is as simple as it can get, and the right one as well. Now, the next step is to get all the x's together. Now, there's 2 x's on the one side and 1 on the right hand. So that one that is the less, I think that one will be better if we take that away. So I want to get rid of the plus x. Write down the minus 2. Now, what have I done? I got rid of a plus x. So I subtracted an x on that side, and now you have to do it on that side as well. Otherwise, it's not true again. So subtract x on both sides. You are left with that. There's only one x on this left-hand side. Get rid of the plus, the minus 1 by adding 1 to get to the x, and adding it on the other side as well. And your answer is then x equals minus 1. This question now, 7.9, solve x. Before you start, I've written down all the steps. The method is as follows. So firstly, simplify each side as far as possible. Now, what can we do there? You can add the 9 and the 1 to get to that 10. And that's about all. And at the right hand side, it is simplified. You cannot get further than that. That's the first one. Now, the second one, see to it that all the x variables are on the same side. Now, it's not necessary to take all the x's to the left hand. You can take the x's to the right hand if you wish. I've done it the other way around. I took that x and subtract the x on that side, and then subtract the x on that side to get to the minus 3x. So now the x is gone on that side. There's only the 1 left. Subtracting the x there, subtracting it there, will give you that equation with a therefore in front. Out of the previous, you'll get that. And now you start to solve your variable. There's only one place, that's x. It's been simplified, both ends. Now get rid of the 10. There's the minus 3x then. You subtracted the 10 to subtract it from 1, get minus 9, and then to get rid of the minus 3 in front, to get to the positive 1 there, you divide by minus 3 on both that sides. 7.10 now. I'm only going to do this one here. But if you finish and you get to the x3, I want you to test if that is the correct answer. So let's first do what the method tells us. First simplify. X minus 3x is that 2x. First simplify. Then you get all the x's on the same side. Add an x there to get rid of that minus x there. Add an x and add an x there. So this step is then with all the x's on the same side. It's only on the left hand side now. Now you take away the plus 4. Can you see the plus 4 is gone there? You subtracted the minus 4 there to get rid of it. So 1 minus 4 will give you that minus 3. And if you divide or multiply by minus 1 on each side, you'll get to the x equals 3. So I have solved the x and I get 3 as an answer. Now to test if that is correct, you take your answer, you go back to that left hand of the equal sign and substitute the x. There are two of them. Not in this one, not in that one, in the given one. Make all those x's and 3, work it out. On that side as well, work it out. And if those two answers are the same, then the 3 will be the answer of the x, the value of the x, if you solved it. Now, I've done it here in this way. The right hand side, that's the x plus 4 minus 3 times x, there it is. Substitute your x with 3 and work that out. And that will be minus 2 if your answer is correct. Now take your right hand side, minus x plus 1, and substitute the x with a 3, then you'll get minus 2 as well. So your left hand side and your right hand side is exactly the same, and therefore the 3 is the answer of that equation. If you don't split it, if you don't split the right hand and the left hand side there, and you carry on with the equal sign in between, then you'll end up with minus 2 equals minus 2, and that is, well, I think it's stupid to write it down. You waste your ink by writing it. We don't want you to write down minus 2 equals minus 2. We know it is minus 2. So do it in this way, otherwise your method of proving that x equals 3 will be wrong. Right hand side on its own, left hand side on its own, if the two is the same. And now of course if it's not the same, then you can answer at the bottom that minus 3 is not the answer. It will not always be correct. Now, when are you going to write down this? Well, firstly, if it's asked, and secondly, just to make sure that you did the right thing. And you cannot, you shouldn't write everything down. If you just test it in your head, make all those x's 3, get your answer, make that one a 3, get your answer, and see whether the 2 is the same, and then you'll know your answer is correct. 7.11 and 7.12. Nothing to simplify in that one. First thing you've got to do is get all your x's together, subtract the x there so that the 5 is the only one left. Subtracting x there means you have to subtract on that side as well. So 2x minus x will give you that x. Write down the answer, don't write the minus x there and forget to put it there. Then I have to subtract 2 marks for you. So just write the answers. It's easier this way. So get rid of the x, the 5 is left, subtract each side, x plus 2 is 5, and now get rid of that 2 so that the x will be on its own. Solving x there. Of course you can go and test it, but it's not asked, and I think it's fairly easy. I am not going to waste my time by testing it. 7.12 now, there's a bracket, so first you simplify 2 times x, 2 times 1 there. Now I see that there is x's on both sides, so get rid of that 2x, subtract 2x on both sides, you're left with a 2 there and with a 1x on that side. to 11 and to 713 and 714. Before I start explaining those two, just have a look at this purple block here. Say for instance I tell you x plus 2 is 10 and then x equals 12. Is it correct there? Is it correct? Now the first thing that pupils do is they tell me no, it's incorrect. Because if 2 plus x is 10, then you have to subtract each side, so the x will be 8. Now, you are quite right, but how did you know that these two equations depends on each other? Is this the answer of that one above, or is it another equation? Now, I didn't tell you, and there's no therefore in front. If I put the therefore sign there, the 3 dots, then it is incorrect. If you have x plus 2 equals 10, then x should not be 12, it should be 8. And then that will become 8. If you have the therefore sign there. So x plus 2 is 10, therefore x equals 8. But, and let me just write it down here. If you have an equation like x plus 2 plus 3, whatever, equals 10, and you have another one, x minus 20 minus 15 equals another one, 100 for instance, then you have two different equations here. The only way to actually combine these two and to tell you that the one depends on the other is by putting that 3 dots in front of it. That one is now correct. X plus 2 equals 10. If you subtract 2 on each side, then x will be 8. But this 2 is 2 different ones. The one's got nothing to do with the other. There's no dots in front of the second one. It's not a therefore. This one has got nothing to do with the other ones. And for that matter, if you want to put another one, why not? Why can't I say x plus 29 or 229 equals 0? That's another one. It's got nothing to do with the previous ones. So I only want to teach you that that 3 dots means something. We have here 3 different equations that has nothing to do with each other, but that top one has. The second equal sign comes from the above ones. So in all these questions, and let's go now to 713, we have the equal sign there. 4x plus 12 equals 0. Take the 12 away, subtract 12 on each side, then you'll get 4x equals minus 12 with a therefore dots in front. Then you divide by 4, therefore x will be minus 3. It's not 3 different equations. The one is depending on the other one. In this case as well, get rid of all these the brackets, and you can add the x and the 4x inside. That's the 5x. You can use the distributive law to calculate that distributive law. Then you can add 15 at both sides and divide by 15, and you will get that 0. Remember this. Remember that those 3 dots in front of each step is very important. You cannot just put it as you like. Must be there all the time. 715, equal signs there. There's 3 dots in front. Remember those. The first thing is in the method, the first thing that you have to do is to simplify. So get rid of the brackets, multiply the 3 with the x and the 3 with the minus 4. Then you can simplify the right and the left hand side. That left hand side, 12 minus 12 is 0. So we have 3x equals to 18, and then you divide by 3 to get to that answer. In this 716, we don't have brackets, but we can simplify the left hand side. That x and 2x is 3x, and the minus 4 and the minus 3 will give you that minus 7. Now I have simplified. Get all your x's together, subtract the x there so that it's not left there, and only the 11 has been left. So subtract the x on both sides, then add 7 on both sides and divide both sides with a 2, and that dot's in front, the therefore sign, which means from the previous. 715 and 7. All three of these questions have the same starting point. Brackets is given. In that one, both sides. In this one, also both sides. And in this one, only on the left. Let's revise the method now. First, simplify. Get rid of that brackets. Then see that all your x's or your variables are on the same side. And then you solve the variable by doing opposite calculations on each side. So for 70 now, get rid of the bracket, the distributive law, 4 times x and 4 times 2 on that side, and 2 times 3 and 2 times x on that side. Now it's been simplified. You cannot add or subtract or whatever on each side on its own. It's the simplest as it gets. Now get all your x's on the same side. There's 2x, subtract it there and subtract it on the other side. You have then the step with the x's only on the one side, and now you start your solving. First the 8, not the 2. If you divide by 2 and you don't do it with all three of them, you'll get the wrong answer. So start with the 8. Get rid of the 8, take it away. That will leave you with 2x, and if you subtract it on that side, it'll make 2 minus 2 there. Then you divide by 2 to get to x equals 1. See that all your equal signs are underneath each other. I did the same here. The first step, I've used the distributive law to get rid of that brackets. Then the second step, I got all the x's on the same side. Subtract the 6x on both ends to get to the 9 there, and the 4x plus 5 there. Now I start my solving. Take the 5 away, that will leave you with a 4x, and if you subtract the 5 on both sides and then divide by 4 each side, you'll end up with x equals 1. Then this one is not that difficult either. It's got only a bracket on the one side. Only thing that is difficult here is the negative 2 there, minus 2. So be careful when you multiply. Minus 2 times 3x is minus 6x. Minus 2 times minus 2 is plus 4. So there you have each side simplified. Now get all your x's on the same side. Take away that 5x, leave you with 26. Minus 5x there, minus 5x to the minus 6 will give you minus 11 plus 4. All the x's are on the same side now. So get rid of the 4 first, subtract it each side, and then you divide by minus 11, and your answer is minus 2. All the equal signs are underneath each other, and all the therefore dots in front of them. There should not be an equal sign there. Please note and have a look at your own work and have a go at that. If it's an equal sign there, change it to that 3 dots. It means therefore, or in other case, out of the previous. That one will give you this. This one will give you that. That one will give you that. And then that one will give you the answer. $7.20 now. First simplify and then get all the x's on the same side and then solve it and get your answer 7. But rather go back now and see by solving x, show that x equals 7. Okay, so we have to solve x. The fact that the x equals 7 is given on top doesn't matter. It only helps you that if you get to the answer, you will know that that was correct. By solving x, show that x equals 7. It's as if you don't know that. Try from the beginning and get x answer, solve x, and if it's 7, then of course that's a positive answer. X will be 7 in this. get rid of the brackets. There you have the 6 and the minus 15. Add and subtract those so that you simplify the left hand side. The right hand side also get rid of the brackets, and if you get there, get all the x's to the same side, and then get rid of the minus 9. You add 9 on both sides to get to the 7. I want you now to go to 721 and 722 because it's more or less the same. I've given you the 7 here, but the question is solve x with a long way, get the answer of x, and then you can show that 7 is the answer of that question. 721 now. Read your question. Prove that x equals 8 is the solution of x in that following. Now, of course, you can do it in the way that you just pretend that you did not see the 8. Take this equation and then go on till you get the answer x equals 8. Then you can do it the same way as 720. But I can also just test the answer. Do you see that equal sign there? We have those part to the left hand side and that to the right hand side, with a solution of x that is going to be 8. So take your right hand side and substitute the x. There's 2 of them. I've simplified it first and then I've substituted the x with the 8, and the answer of that left hand side will be 5 then. If you take the right hand side, 5 minus 2 times x minus x, you have to simplify first. X minus x is 0, so there we have a 0 number. We don't have to substitute the x there, but if you want, you can substitute the 2 x's there. You will also get the 0 there because 8 minus 8 is 0, and that answer is also 5. So both of the answers are 5. Your left hand side and right hand sides are equal, so x is the solution. I tested 8. They gave me the 8. I didn't work it out. I only tested it. Remember your left hand side and your right hand side. The method to test or to prove is like this. In 722 we have 2 questions. The first one, I've given you the equation there. The first one then, is the equal sign true for x equals minus 5? Is the equal sign true? That means, is minus 5 the solution of that equation? Now test it. You have the answer. Test it. Go and substitute in the left hand side the x with a minus 5, and then the x there in the right hand side also minus 5. Now if you do it, I've used the distributive law first and then substituted the x with a minus 5, and then I'll get to minus 8 if you do that in the proper way. The right hand side, if x equals minus 5, first the distributive law to get rid of the brackets, and then the substitution, x with minus 5, and if you do that you'll get minus 18. Now minus 8 and minus 18 is not the same, so the left hand side is not equal to the right hand side. That means minus 5 is not the answer of that x. It's not the solution for x. Let's try the second one. Is the equal sign true for x equals plus 5? Now I think that'll be okay. Do the same as you've done above. Go on and substitute the x with a 5 on the left hand side and on the right hand side, and can you see in both cases there's a 12, so the left hand side is equal to the right hand side, and 5 is therefore the solution of this equation. Now if they didn't give us that minus 5 or whatever, we shouldn't do it this way, because you cannot actually guess the answer and then try and see whether it is the answer or not. You have to solve the x if they ask you. If they want you to prove that it's the correct answer, then you can test, and you test with the left hand side and the right hand side apart from each other. We have here simple fractions, but this is actually a difficult question. If you have to solve x and you have a fraction like that divided by 2 in it, we don't like fractions. We don't like brackets. If there were brackets, that's the first thing that you've got to get rid of, and fractions to me is the same. Get rid of the fractions so that your question can become easier. Now the way to do that is to multiply with the LCD. We have a 2 there. Now, remember, LCD is the lowest common denominator. Now all the denominators of all those other terms are 1. So it's a 2 and a 1, so the LCD is then a 2. And then by just counting the number of terms, 1, 2, 3, 4, 5 terms in there, now multiply each one with that LCD. The first one multiplied with 2 will give you 3x. The second one multiplied with 2 will give you 2x. That one will give you 32. And both of them as well. X times 2 is 2x, and x times minus 1 is minus 2. And when you look at this part of your question now, it'll look the same as all the previous ones without the fraction. I got rid of the fraction by multiplying with the LCD. Now the method is to simplify first, and that's what I'm going to do. 3x plus 2x is 5x minus 32 then. In the simplest form, the left hand side. The right ones are exactly simplified and cannot be simpler. Now the next one is to get all your x's on the same side. Get rid of that 2x, subtract 2x both sides, and then take away that minus 32 by adding 32 and then dividing by 3 to get your answer, x equals 10. So by simplifying that equation, in this case you have to multiply with a LCD. The method is still the same. Simplify, then get all your x's on the one side, and then solve your x. 723 now. I have a fraction in there, third. Simplify first, multiply with the LCD. Now the LCD is a 3. Each term by 3. 3 times x is 3x. A third times 3 is 1. And 2 times 3 is 6. Now get rid of that 1 first. Subtract it on each side. And then you divide by 3. Your answer is 5 over 3. And that's not wrong. That's actually very much correct. You can write that as 1 and 2/3, the improper way, and then the mixed way. Don't think that if you get a fraction or that 5 cannot be divided exactly through 3 without a remainder, that your answer is incorrect. 5 can be divided by 3. It is 1 and 2/3 the answer. Now 724, I can do that in this video as well. I have a fraction there, 2. We have this fractions here. We don't like the fractions, so multiply by 2 to get it in a simplified notation. Multiply by 2, and that one by 2, and that one by 2. Each term has to be multiplied by the LCD. And if you've done that, then you can start solving your x, because that is in the simplest form. Take away the 2 on both sides, and x will be 6 then. 725. I have a big fraction. It's only one term, not two terms. You cannot write that as 2. If you want to do that, each one of those above must be divided by 4. Then you'll get the 2 fractions equals the 2. But you can do it in this way as well, as long as you know there is only one term there. So the LCD will be 4. Multiply this one term, you multiply once by 4, and the other side also you have to multiply with 4. If you multiply by 4 over 1, the 4's cancels out, and 3x minus 1 is left. and 2 times 4 there is also 8. Of course, you could have cross multiplied in this case as well. We have one fraction there. Just write the 2 over 1 on that side, and then you cross multiplied, and you will also get that answer. Now get rid of that minus 1 by adding it on both sides, and divide by 3, the opposite, to get to x equals 3. 726 equation. The LCD is 5 there and a 1 there and a 1 there, so the LCD is 5. So multiply by 5 each one of those 3 times. Then multiply by 5, get minus 2, multiply by 5, multiply by 5, and your 3 dots in front. Therefore it's out of that one. That one gives you that one. It's not two different equal signs. Now get rid of the minus 2 by adding it both sides, and then divide by 5. Now 52 over 5, that's the improper fraction, and you can make it a mixed fraction. That is better always. 10 and 2 over 5, the answer. 727 now. We have two fractions. There's a 3 as a denominator and a 2 as a denominator, so the LCD will be 6. So you have to multiply that one with 6, the minus x with 6, and the 9 over 2 with 6. Now multiply with 6 over 1, 3 goes into 6 2 times, 2 times 4 is 8. That one multiplied by 6 is minus 6x, and that one multiplied by 6, the 2 goes into the 6 3 times, and 3 times 9 is 27. Take away that plus 8 by subtracting it, so minus 6x is 19, and then you can divide by minus 6 each side. That improper one, have a look at the plus and the minus that have to be divided, so your answer will be negative. 6 goes into 19 3 times, and 1/6 is left. 729, 3 terms. LCD is 2. Get rid of the fraction. You have to simplify first. Get rid of the fraction, so that one multiplied by 2 is that 3x then, and both of them have to be multiplied with 2, so you can actually give that answer in that one's place. So that 1 times 2 is 2x, and the minus 1 times 2 will give you that 2. I've written it in this way, but it doesn't really matter. You can actually multiply each one separately and get to that answer. That's a distributive law that I've used to get rid of that bracket, but actually from that point you can write down this one, take the 2x away there, and then you'll end up with x equals minus 2. 730 and 731. Yeah, we have 3 terms in each equation. Solving x is the question. You have to simplify first, multiply with the LCD. Now there's a 3 and there's a 3, so multiply by 3. That one by 3 gives you 4x. That one with 3 is 3x. You usually forget that one. So x times 3 is 3x, and a third times 3 is 1, so minus 1 at the end. Take away 3x both sides, then x will be minus 1. 731 now. Also 1, 2, 3, 4 terms. The LCD is a 2, so just multiply with 2 throughout the whole equation, the left hand side and the right hand side, each one multiplied by 2. X times 2 is 2x, so half times 2 is 1, minus 2 times 2 is minus 4, and x over 2 times 2 over 1, the 2's cancels out and the x stays. Get the x's on the same side, so take away that x there by subtracting it. Do that on the other side as well, and then you have x minus 1 equals minus 4. You add 1 on both sides and you'll end up with x equals minus 3. This one looks more difficult than it really is. First, count the number of terms. 1, 2, 3, 4, 5 of them. both sides of the equal sign. There's 5 of them. We have to get rid of that fractions. We don't like fractions. It doesn't work that well. We rather get rid of them as soon as possible so that the question gets more easy. Now there's 5 of them and the LCD is 4. So multiply each of those 5 with 4. That one multiplied by 4 is 4x. A half times 4 is 2. X over 4 times 4 over 1 will leave you with that minus x. The 4's cancels out. That one multiplied by 4, the 4 cancels out and the x is left. That one as well multiplied by 4 over 1, the 4 cancels out and the minus 3 are left. Now you can simplify a little further because 4x minus x is 3x. 3x plus 2 on that side and x minus 3 on that side. Then get rid of the x on that side. All the x's got to go together. So take away that x there. Minus 3 is left there. The x went to that 3x there, subtracting it there. And the 2 is subtracted on that side to give you that minus 5. Now I know there's 2 steps done in that one. If you can handle that, that's okay. Otherwise, first get the x's to the same side and then take care of that plus 2. But now the 2, to get rid of it, you have to divide by 2 and divide by 2 there. Minus 5 over 2 will leave you with a mixed fraction of minus 2 and a half. In 733 there's an x and a y. Handle the y as a constant and solve the x. That is what is asked. So just don't see the y. Do it as if you are only solving x. Now let's look at it. There's an equal sign. The LCD is 12. 3, 4 and 2. The LCD is 12. Multiply that one with 12, that one with 12 and that one with 12. Each of them, so the fractions are gone. Now there's the x and there's the y. We don't want the y's together with the x. We want to solve x. So get rid of the minus 9y by adding it both sides. If you add 9y there, then the 8x is the only ones left there, and the adding of 9y will be at the other end. Now get rid of the 8. You divide by 8 to get to that 1x. So that whole thing there, the whole one, each one of them, both of them, divide both of them by the 8. If you multiply or if you divide, you have to do it to the whole left hand side or the right hand side. So x is equal to 6 plus 9y over 8. The x is made the subject of this equation, or we solved x and the y is a constant, whatever.